All right, this video is going to help with 4-7, which is Leontief. I don't know how to say his name. Input-output analysis. Leon. I don't even think I've ever tried to say his name. Either way, this is actually one of the newest things I teach across the board, which is kind of a crazy thought. Most of the mathematical concepts that we learn are not new. This is from the 80s, an economicist, I can't even say it, never mind. I give up today. I can't say anything. He came up with this and it really changed economics. So an economist, oof, can't say any words today. What we're going to look at first is a two-industry model. Okay, so our two industries are going to be C1 and C2 just for this example. And we're going to start with what we call our technology matrix. This is our input and output between the two companies. So what do I mean by this? This spot, column 1, row 1, A11, is the input from C1 that produces $1 of C1. So how much, for example, I think about how much electricity does it take for me to produce electricity? Kind of idea. Okay, so that is that spot. The next spot, which is right here, is going to be the input from C1 to produce $1 of C2. Okay, and then so forth for the next two. So for the bottom row here, the input from C2 to produce $1 of C1, and the last spot there is to produce $1 of C2. Pause, write that example down. You have a couple questions similar, kind of the idea of where this comes from. So here's where it gets a little weird, but we are going to say our solution is equal to M times X plus D, which is solved by the identity minus the matrix, do the inverse, times it by our D. Take a second. I mean, it looks way harder than it is, okay? Assuming that this has an inverse as well. So notice that assumption. So pause, write that down. What am I actually saying? I am saying, if this is my first example, I'm going to call this A, this E, and I'm going to say I need 0.1, 0.5, 0.26, 0.3, and this would be A and E also. So this is two industries. And if I asked a question like, how much of A, whatever A is needed to produce $1 of A, it would be 0.1. Okay, so you could be asked questions from that. If I want to find the solution of this, the first thing I'm going to start with is to find the identity minus the given matrix. And the matrix, again, is called the technology matrix. We'll do one from a word problem as well. So we want to start with what is the identity. This is a 2 by 2, so our identity goes 1, 0, 0, 1. And we would like to subtract off what we were given, which was 0.1, 0.5, 0.26, and 0.3, okay? So if I subtract, if they have to be the same size, they are, and then we just subtract what we're given. Each spot given. So 1 minus 0.1 is going to give me 0.9. 0 minus 0.5 would give me negative 0.5. 0 minus 0.26 is negative 0.26. Last one, 1 minus 0.3 is 0.7. Okay, and then the next thing is to find the inverse of this. So we're going to find the inverse of this new matrix that we found, right? So we can use technology for this now. Really, the determinate method is pretty quick. So you could do that as well. So I think the determinate method might be quicker than the calculator, but I'll show it on here again because the 3 by 3 we definitely want to do. Oops, now I have to hit matrix, edit, and I would like this to be a 2 by 4. Why 4? Because I have to put in, oops, my identity. So what I was given is here. So we have 0.9, enter, negative 0.5, enter, 1, 0. Then the bottom row is negative 0.26 and 0.7, and then 0, then 1. And then I'm going to hit matrix. Oops, I have to clear out of everything because this thing's weird. And I'm going to hit matrix, and then I need to go to math, find a reduced row echelon form, and now I'm going to tell it of matrix A, and here it is. Well, I guess I can see it all. So the inverse, okay, good. I had a different answer on my paper, but it was just because I wasn't looking in the right spot. So my inverse would be 1.4, 1.52, and 1.8. So far, everything we've done is tedious because it'll take up paper, but it's not been difficult, right? We subtract the identity off, or the matrix off of the identity, we do the inverse. Then from here, I'm going to use this with our demand. Now, I'm going to say that my demand is equal to 4 and 2. So demand would be like maybe your total that you have of each thing to use. So a lot of them are electricity. How much electricity do I even have to use, kind of idea. So what I do from here is I am now going to take this matrix here, and I'm going to times it by this one, 1.40. Oh, I wasn't given the demand on this one. I'm using the demand on the next one. Well, either way, I mean, this demand isn't on my exact problem, but I'm going to finish it anyway. So if I would have had to have been given the demand from the beginning, and now we should know that if we take this I minus the matrix, the inverse, and I times it by demand. Demand is second. So I would go 1.4, 1.52, 1.8, and I want to times that by the 4, 2. Remember how we do this? This one's a 2 by 2. This one's a 2 by 1. So these match, so I can do it. Can't even see what I'm writing. So these middle ones match, right? So we can do it, and the answer will equal a 2 by 1. Okay, so then we do this one times this one times this one, and then add them together to get our first number. So I'm going to cheat, use the calculator. So 1.4 times 4, 1.4 times 4 plus 1 times 2, which is 2, is going to give me 7.6. And then the last one, this one we did times this one. Now this one times this one would be 0.52 times 4 plus 1.8 times 2, which is 5.68. Ta-da. So this is the process for input output. Now, this is one section. I've had a lot of people focus on this and try to do this in their test for all the other sections. This is only for input output, and it will say Leontief's. I think that's how whatever. We're going to say it any way we want. It's called Leo's method. Okay, so let's look at a couple examples. Okay. All right, I'm going to walk through this one. So economy is based on two industry sectors, coal and steel. Production of $1 worth of coal requires an input of 40 cents from coal and 20 cents from steel. The production of $1 worth of steel requires an input of 40 cents of coal and 20 cents from steel. Find the output, blah, 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 for a final demand. So the rest is going to give us our demand. So if we go to set this up, we're going to think of it as coal and steel, coal and steel. So 40 cents of coal to produce 40 cents of coal. So be careful. Production of $1 worth of coal requires an input of 40 cents from coal. Okay. And then this one, a production of $1 worth of coal. So this one has to go down here, and that's going to trick you with the wording. So then the next part, production of $1 worth of steel requires 40 cents from coal. So we need 40 cents of coal to produce the steel. Input, output, input, input, output. I think that maybe if I think that the book kind of does this in some of them. That might be kind of helpful. So you have to be careful the way it's worded. It could go down, it could go across. By far the trickiest part. You just have to practice a couple times and then I think you'll be fine. Okay, so this is an input-output problem, so it has its own method of solving. Okay, and we're trying to find the equilibrium, right? Where these conditions where these industries have enough output to satisfy the demand of each other. That's kind of the idea here. Okay, so what would be our first thing to do? Would be to subtract the identity matrix off. So identity minus this. So 1 minus this is this. 0 minus this is this. 0 minus this is this. 1 minus this is this. So I subtracted off the matrix from the identity. What would be next would be to find the inverse. Technology, totally fine. You can use the matrix Desmos calculator or your handheld, or a different calculator if you can find an app that you like. It's totally fine. Then what do I do once I find that inverse? I times it by the demand. So 2 times this and 1 times this, add them together, I get this. 5.5 times this, 1.5 times this, add them together, and I get this. Okay? All right. So what if you have a 3 by 3? I want to at least show you how to set this one up. Again, most of these are word problems. Okay, so an economy is based on 3 sectors: agriculture, manufacturing, and whatever. A production of $1 worth of agriculture requires 40 cents from agriculture, okay? 40 cents from manufacturing, and 20 cents from energy. All of these are giving us $1 of this, okay? Then the next row says a production of $1 worth of manufacturing requires, so we're getting out the manufacturing, it requires 30 cents from this one, 30 cents from this one, and 30 cents from this one. The last one would be energy, and we can see that there. So where do we start once we're doing an input-output? We start with subtracting off the identity. I always say it backward. Subtracting your matrix from the identity. So subtract those. I'm going to get here. Pause, do that, make sure you do it right. What would be the next idea? Inverse, right? Inverse of this is not real pretty. It is this. You could get decimals, I don't know. And then you're going to times it, right? So this one times this one, this one times this one, this one times this one. Add them up and we get this, and so forth. So you can do this input output with the 3 by 3 as well, and you will have a couple problems. This homework is a little shorter because you have a lot of work on one problem. Just be careful setting this input output up. Please feel free to read through the PowerPoint if that's going to be helpful for you to get a little bit more information. I think this guy is kind of interesting. And I don't know if, to me, if he is interesting only because he was newer when he came up with this, or it's newer. Like I was alive when he came up with this, maybe in, elementary school, but I was still alive. Okay. Remember, this is only going to be a couple questions at the end of your test. It's our last section. So you're probably taking your test soon. It is not the whole idea. When I say to solve something by using a matrix, this is not the method. This is an input output method for businesses.